The first thing to remember about the normal distribution is that it is a universal principle. For example, like pi or Pythagoras. So you will always have 68.26% of your values between -1 standard deviation and +1 standard deviation. You'll also have 95.46% between -2 standard deviations and +2 standard deviations. And conversely, you'll have 99.73% between -3 standard deviation and +3 standard deviation. The next thing is it's symmetrical. That's important, right? So we have 34% between -1 standard deviation and the mean here. And then we have 34% between the mean and +1 standard deviation. The same thing we have between -1 and -2 standard deviation, 13.6%, and between +1 standard deviation and +2 standard deviation, 13.6%. That is always the same. And the advantage of this is that once you look at z-scores, right, if you translate that to z-scores, this is where we want to go, right? Imagine we have standard deviation terms, right? And z-scores are a metric in standard deviations. So let's go down here where we have z-scores, right? So in the middle here we have the average is 0, right? Z-score of 0 is the average here, 0. And then -1 standard deviation is a z-score of 1. +1 standard deviation is a z-score of +1. +2 standard deviation is a z-score of +2. Right? And we're going to leverage that uniqueness of the normal distribution, that it's universally applicable. We're going to leverage that and use it for our hypothesis testing. Right? We're going to know that, for example, if you want to know the probability of getting a value that's in this area, that's 3 standard deviations above the mean, right? If your values are normal distributed, you know that the chances of getting a value of 3 standard deviations or higher is 0.13%. That's the number or the percentage of values that are actually in this area. Right? At the same time, we know, okay, to get a value of +2 standard deviations or higher, well, there's only 2.3% of the values in this area, right? 97.7% are in the area here, and 2.3% are in the area here, right? I did 100 minus 100% minus 97.7 gives you that 2.3%. At the same time, you have 2.3% in this area, right? Lower than -2 standard deviations. So we're going to use this principle and apply it to hypothesis testing.